This is our third lecture on Chapter 7, Continuous Probability Distributions and the Normal Distribution. And this is our final lecture for Chapter 7. So we do 3 lectures. This one is going to be the lecture that basically ties everything together. Okay, we're going to do more examples of using NormalCDF and InvNorm. So in example 7.13, consider a normal distribution with mu mean equals to 75 and the standard deviation sigma equal to 5. Find the data value in the distribution that cuts off the top 25% of the data values, represents the 30th percentile, has a percentile rank of 55, cuts off the middle 40% of the data values. Okay, so you should notice that this problem is different from other problems we've seen because the question is asking us to find the data value, not to find the proportion of area. Okay, so to find the data value that cuts off the top 25% of the data values, it's basically a raw score. A data value is a raw score, and it's the same raw score that cuts off the bottom 75%. So let's draw a picture. You're going to start with an empty bell curve, and you're going to label the center with a mean of 75 and a standard deviation of 5. The top 25% is basically the upper 25% of area. The data value that you're looking for is this data value x, the value that borders on the top 25 and the bottom 75. Okay, so this is the data value that you're being asked for. So when the question asks you to find a data value, the question is asking you to find some quantity on the horizontal axis given some percent of area. So you know that 25% of the area is to the left of this unknown data. 25% of the data values are to the right of this unknown data value, and therefore you can infer that 75% of all the data values fall to the left of this unknown data value. So we are asked for a raw score, and we have area to the left, which is 0.75, because we're going to always express area when dealing with our calculator. Area is going to be input in decimal form. So we are going to use InvNorm to get the raw score that cuts off the bottom 75%. Recall that we used InvNorm to get a z-score. Well, we could also use InvNorm to get a raw score. So let's go to our calculator. We're going to go to InvNorm like we have in the past, and we're going to enter an area as a decimal, and that's going to represent the area to the left. And then when we look at the mean and standard deviation on the calculator, we are going to enter the mean and standard deviation as was provided to us in the problem. So instead of 0 and 1, we're going to enter actual numbers here. So the mean in our problem, 75, and the standard deviation is 5. So let's go to our calculator. Recall that InvNorm is second DISTR. InvNorm for me on this calculator is A. No, I'm sorry. InvNorm is 3. I just skipped right by it. There we go. Okay, InvNorm 3. Okay, in InvNorm we're always going to enter the area in terms of decimals, and it's the area to the left. So 0.75, even though the problem provides to us 25%, that's the area to the right. We have to enter area to the left. Then we're going to change mu to 75. and the standard deviation to 5. Okay, so these values were provided in the problem. Then we go down to paste, hit enter, and enter again. And you see that the number that comes out is not a z-score. Clearly, it's too large to be a z-score. It's also not an area under the bell curve because it's not expressed as a number between 0 and 1. This number is a raw score, 78. It's a raw score, or considered to be one of the data values of the distribution. So let's go back. And in the PowerPoint, I am rounding to 2 decimal places. If you get a question like this on web work or on an exam, you will be told how to round, okay? So there's no question on how many places to round to. If it says round to 2 decimal places, the answer would be 78.37. Okay, so InvNorm again will give us a value on the horizontal axis. If we don't enter 75 and 5, if we leave it as 0 and 1 like we did in the past, the value that we'll get will be a z-score. But if we enter the raw mean and the standard deviation, that will give us an actual, when we paste this, we're going to get an actual data value from the distribution. Okay, we're going to find the score that represents the 30th percentile. So again, this problem is asking us to find a raw score. Okay, so remember that the 30th percentile is the data value that has 30% of the distribution below it. And when we say below, in terms of the bell curve, we mean on the left side. 30% of the distribution is on the left side. Okay, so the 30th percentile is a data value, an unknown data value that we're going to label as x. And by definition, the 30th percentile is the data value for which 30% of the area is below it. Okay, so we shade in approximately 30% of our bell curve on the left-hand side, because when dealing with percentiles, we're always dealing with area to the left or area below. And the data value that cuts off that bottom 30% is the unknown data value x, which is what we're trying to find in this problem. So again, we're asked for a value on the horizontal axis, an unknown quantity x on the horizontal axis. And whenever that's the goal of a problem, you will use InvNorm. Okay, the area to the left is going to be expressed as 0.30 or 0.3, and we're going to use InvNorm to get this unknown raw score x. So we're going to go to our calculator. The area to the left will be entered as 0.30. The mean again is 75 and the standard deviation is 5. So putting those 3 quantities into InvNorm, you get 72.38. Now let's just verify that that's what comes out of the calculator. Okay, we are going to enter area to the left. Area to the left is 0.3. Mean is 75, standard deviation is 5, and paste it. Okay, so we get 72.377, which makes it 38 if we were to round to 2 decimal places like I'm doing in the PowerPoint presentation. Okay, part C. Find the data value that has a percentile rank of 55. So this is another way of pretty much saying the same thing as part B, except the area to the left is 55%, not 30%. The data value that has a percentile rank of 55 cuts off the bottom 55% of the data values in the distribution. So in our diagram, let's draw a diagram. We have a bell curve, and we recognize that half of the bell curve is 50%. So 55% has got to be a little bit more than half. So you make this line a little bit to the right of center, and you shade in all the area to the left of that vertical line. Now that value for x is the value that cuts off the bottom 55% of area, and that's what we're looking for. So the bottom 55% of area is expressed as 0.55. So we will use 0.55 on our calculator, and we're going to go to InvNorm again, this time putting in a 0.55 for the area to the left. Okay, every problem in this problem set has the same mean and standard deviation, so we don't have to change 75 and 5. Our answer here, 75.63. That's the data value, 75.63. Okay, now I just want to verify with you why this makes sense. You're looking for a raw score in the question. The question is asking you for a data value, which is a raw score. If you're told that the mean of the data set is 75, then your raw score most likely is going to be somewhere in the 70s, maybe the 80s, maybe the 60s, but those would be typical raw scores for this distribution. Okay, because the mean is 75. So you would be incorrect if you came out with a number, say, near 0, because that would probably be a z-score. Okay, so this question is giving us a mean of 75, so it makes sense that the data value with a percentile rank of 55 is a little bit more than that, 75.63, because 55 is a little bit right of center. Okay, because we know center is the 50th percentile, so 55 would be a little bit to the right of that. Okay, part D asks us to find the data values that cuts off the middle 40% of the data values. So drawing a picture again, the middle 40% has to be a symmetrical middle, so that 20% is on the left side of center and 20% is on the right side of center. The data values that you're looking for are x1 here labeled as x1 and labeled as x2. Okay, in the center we have 75, our mean, and sigma is 5. Now when we get an answer for x1, we are going to expect that it is less than 75. And when we get an answer for x2, we're going to expect a number that's greater than 75. Okay, now we don't have tools on our calculator to immediately give us an answer for x1 and x2. We have to do a little bit of work first, because remember, InvNorm, which is the tool on the calculator that can give us a horizontal value, the InvNorm only takes area to the left, and we do not have that right now. So we have to recognize that if this is 20 and this is 20, this is the middle 40%, well, we have to recognize then that this piece of unshaded area is the bottom 30%. Because we know that half of the bell curve is 50%. So if this piece is 20, this piece must be 30. So this is the bottom 30%. So the area to the left of x1 is 30.3. The area to the left of x2 would be 30 plus 20 plus 20, which would be 70% or 0.7. Okay, so the score that we're looking for is the score. X1 is the score that separates the bottom 30% from the top 70%. So we're going to go to our calculator, using an area to the left of 0.3, a mu of 75, and a standard deviation of 5. Putting those three things in the calculator, you get a score of 72.38. We did calculate this one earlier. Okay, so here if 75 is in the center, it makes sense that this number on the left-hand side is less than 75, 72.38. The area to the left of x2 we had just said is 70%. Okay, so here's x2, and if we look at all the area in the bell curve to the left of it, we have 20% plus 20% plus 30%, and that makes 70%, or 0.7. So we're going to go to the calculator and we're going to find x2, which represents the score that separates the bottom 70% from the top 30%. Okay, so this is the bottom 70%, this is the top 30%, and x2 is the raw score at that border. So we're going to enter 0.70 for the area to the left. The mean is 75. The standard deviation is 5. Entering those three values, you get 77.62, which makes sense because it's greater than 75. So for x1, we had a 72.38, I think. Yes, 72.38, and for x2, 77.62.